Hi everyone, welcome back to CFI Helper. Today we're going to be going over some practice questions and solutions on the topic of fronts in meteorology. And these types of questions can often come up on your written exams, and it's something that students often struggle with, which is why we're going to be going through it today. I'm going to show you guys the question on the screen. I'll give you a second to pause the video. You can read out the answers, think about what answer you would choose on your own, and then we'll go through the solution together. Just a quick disclaimer before we move on. A lot of my viewers aren't subscribed to my channel, and it would actually be super helpful if you took a second just to hit that subscribe button before we continue to help me pop out more videos like these. So our first question today is going to be, what sequence of clouds can you expect with the approach and passage of a warm front? So take a second here, pause the video, and then we'll go through it together. So the answer for this question is B. We're going to get cirrus clouds, cirrostratus clouds, altostratus, nimbostratus, and stratus. And let's talk very quickly about why. Let's say we have our cold air here, and we have our warm front advancing and moving in. We know that when a warm front is advancing, it's going to have more of a gradual slope, right? And part of this answer comes from the fact that it is more of a gradual slope. So as that warm front is approaching and passing, we're going to start with some high clouds over here, right? And then they're gradually going to lower and lower and lower and lower. A lot of these cloud types end with the word stratus. That tells you more about a warm front too, because we know that with warm fronts, the clouds are more layered and they don't have as much vertical development. You're going to get a lot of steady precipitation with these types of clouds. One way you can remember this for your written exam, it's not perfect, but it's an acronym that you can use. Sorry, that arrow looks interesting. Is you can remember the acronym SECANS, okay? And that'll tell you the sequence of clouds you can expect with the approach and passage of a warm front. So quickly, we can go over why some of the other answers aren't necessarily correct. Here, this one starts with nimbostratus and then goes on to altostratus, cirrostratus, and cirrus. These are starting from low clouds and then going up to some higher clouds, which is why this answer wouldn't necessarily be correct for this question. We have the approach and passage of a warm front. We're starting with higher clouds and then those clouds are lowering, right? So this answer wouldn't be correct. C starts with cirrostratus, cumulus, and then cumulonimbus. We know that with our warm front, we're going to have more horizontally layered, less vertically developed clouds. And in this answer here, we have cumulus and cumulonimbus. Those are pretty vertically developed and they're going to come with quite drastic weather changes. So this one also wouldn't be correct. And then that kind of brings us to the same conclusion for D. We have cumulus, cumulonimbus, and then cirrus, stratus, and altostratus. So once again, we have a lot of vertically developed clouds here, which we won't necessarily expect with the approach and passage of a warm front. If this question were more tailored to a cold front, then yeah, you might actually expect cirrostratus and then cumulus and cumulonimbus, because the cold front has more drastic changes, right? The cold front is advancing a lot faster onto that warm air mass, so you're going to get a lot of vertical lifting, and most likely C would be the correct answer for that. Question 2 is, what typically happens to the pressure as a cold front passes? Once again, I'll give you a second to pause the video. Okay, so the correct answer for 2 is going to be B. The pressure is going to drop, and then it's going to rise rapidly after the passage. Let's think about what's happening in this question, okay? So in this case, let's say we have warm air here, and then we have a cold front moving in, and let's say this is our cold front, and it's trying to undercut that warm air. So what is happening to this warm air as the cold front is advancing? Is it rising or is it sinking? It's going to rise, right? We're going to get some rising air because the colder air is undercutting it. And a way I like to think about what's happening to the pressure here is think about the weight of the column of air over the ground here. As that cold front is advancing and it's pushing that warm air upwards, the weight of the air over this ground is going to feel lighter, right? You have all that air rising upwards. So because of that, the pressure is going to drop. And then the rising rapidly after passage, let's say that the cold front has completely come in, okay? And now we're only worrying about the cold front. We just have a bunch of dense air over the ground now. The weight of the air column now is going to feel quite heavy, right? Because of that, it's going to rise rapidly. The reason why it's going to rise rapidly rather than staying steady and gradually rising is because of the nature of that cold front. The cold front is steep and it moves very quickly. So that's why we're going to have the pressure rise rapidly after passage. However, if this question were tailored towards a warm front, you would kind of have the same situation where the pressure drops. Let me draw a quick diagram again here. Let's say you had the warm front coming in. Once again, this warm air, once it's advancing, it's rising, okay? So as it's approaching, that pressure is going to drop because you have all that air being risen upwards. However, in this case, it would actually be C. With a warm front, instead of your pressure rising rapidly after passage, your pressure is going to stay steady and then gradually rise. And this kind of has to do with the nature of a warm front. It's more of a gradual slope. It's advancing slower. So although the pressure drops, once that warm front has passed, now all we have is that warm air over the ground. So we don't have as much of that rising action as we did before. Your pressure is going to stay steady and gradually rise, instead of rising rapidly like a cold front. Number 3, what type of precipitation can a pilot expect when flying towards a winter warm front? I'll give you a second to pause the video. Okay, so our answer for number 3 is going to be D. We're going to get snow, ice, freezing rain, and then rain. Once again, we can draw this out super quickly. Let's say we have some cold air here, and then we have that warm front advancing on it, and we're flying towards it. So we're coming from here. When you're flying in from this direction, right? Let's say you're just starting in the cold air. You're most likely just going to get snow, right? Snow is going to be falling through here. And then once the warm and the cold air mix together, you're going to get freezing rain over here. However, with that freezing rain falling into the cold air, you're going to get some super cooled water droplets that might actually turn into ice pellets. So you might have some ice pellets just ahead of that freezing rain. And then once we've passed those sections and we're more in the warm, we're going to get some rain over here, okay? So when you're flying towards a winter warm front, you're going to get snow, ice, freezing rain, rain. Question 4. A cold front passes your airport. Which is expected? I'll give you a second to pause the video. The answer for this question is going to be C. And we can kind of go through this with process of elimination, okay? So we know that D is absolutely not going to be an answer because when the cold front is passing, whether a cold front or a warm front is approaching, just remember that your winds will always veer and increase, okay? So already knowing that, we know that D cannot be correct because we are going to get a wind change, so it can't be D. We know that it can't be B because the winds are backing and the winds are always veering and increasing. Veering means turning clockwise. So the winds are always veering and increasing. So now we have A and C, okay? We have winds veer and we also have winds veer here as well. Those are both correct. And then we're talking about temperature here. So in A, the temperature is rising, which doesn't really make any sense for the cold front passing. So when that cold front is passing, the temperature in the beginning might be a little warm because it's mixing with the warm air that was above the ground. However, when you're behind it over here, the temperature is going to drop, okay? So your winds are going to veer, your temperature is going to drop. We don't expect stratiform clouds with a cold front. With a cold front, we have a steep slope and it's advancing quickly. So we're going to have more vertically developed clouds, which is why we can expect cumuliform clouds. And then again, this ties into we're going to be expecting heavy showers or thunderstorms, not necessarily like light, steady precipitation, right? Because that's what we'd expect with the stratiform clouds. So that's why in this question, C would be correct. Question 5, an occluded front occurs when? I'll give you a second to pause the video again. And the answer for this question is going to be C. An occluded front occurs when a cold front overtakes a warm front. Now, this is kind of what it would look like if you had to draw it out. You would have, let's say, some cooler air ahead, but the whole point of the occluded front is that the cold front is catching up with the warm front. The speed of that cold front is really fast, and it's going to be advancing on that warm front quickly. It's going to undercut that warm air and lift it up, resulting in a trough of warm air aloft, otherwise known as a trowel. This is going to lead to it looking a little something like this. Your warm front gets lifted up a lot more, and because of this, you kind of have a combination of a cold front and a warm front. So your weather will also be a combination of the two. Question 6. This is a topic that doesn't get covered too often, but I've had a question similar to this come up on my written exam, and it's really important to know. The name of a front is derived from the blank, while the type of front is derived from the blank. I'll give you a second to figure out what your answer to this may be. So the answer to question 6 is C. The name of a front is going to be derived from the cold air mass, while the type of front is derived from the advancing air mass. I want you to keep this in mind. The next question is going to make this a little easier for you to understand because we're actually going to name a front. So, moving on to question 7, a continental polar air mass and a maritime tropical air mass meet. The maritime tropical air mass is advancing on the continental polar air mass. How would you name this front? I'll give you a second to pause the video. Okay, so the answer for this question is going to be C, continental polar warm front. If you remember from the last slide we just did, what did we say the name is derived from? We said it's derived from the cold air mass, right? Whereas we said the type was derived from the advancing air mass. So in this situation, what would the cold air be? We have a continental polar and maritime tropical. So the cold air would be our continental polar air, right? The continental polar air is usually coming from up here, whereas maritime tropical is coming a little bit from over here. And then I said that the maritime tropical air is advancing on the continental polar air. So now the type is going to be derived from the air that's advancing. The maritime tropical air, in comparison to the continental polar air, is going to be warmer or colder. Warmer, right? So because of that, our type is going to be a warm front, if that makes sense. So that's why your answer for question 7 is going to be a continental polar warm front. Question 8. The severity of the weather at a warm front is dependent on the... I'll give you a second to pause the video. Okay, the answer for 8 is going to be C. The severity of the weather at a warm front is dependent on the moisture content and stability of the warm air mass. This one also super important. I think I got this one on my written as well. So at a warm front, it's dependent on the moisture content and stability of the warm air mass. At a cold front, it's kind of the same thing, except it's this plus the speed at which the cold air is advancing. So with a cold front, it's dependent on, yes, the moisture content and stability of the warm air mass, right? Because that's what the cold front is lifting, but it's also dependent on the speed at which that cold air mass is advancing. If that colder air is advancing very quickly, we're probably going to be having more severe weather than if the colder air mass was advancing more slowly. Question 9. Which type of cloud would form at a front when the air mass is moist and stable? I'll give you a second to pause the video. The answer for this question would be C, stratiform clouds, right? So we know that the weather associated with a front has to do with the moisture content and stability of the warm air mass. So when the air is moist and stable is one of our keywords here, we're going to be getting less vertical development in our clouds, right? So we're going to be getting stratiform clouds. For example, we know that a warm front comes with cirrus clouds, cirrostratus clouds, altostratus clouds, nimbostratus, and stratus clouds. Whereas if we had moist and unstable air, what will you get with unstable air? You're going to get a lot more lifting action, more vertical development, right? So you'll probably get some cumuliform clouds, like cumulus clouds or cumulonimbus. So that is why the answer for 9, moist and stable air, is going to be causing stratiform clouds. Question 10. Which statement about unstable air is correct? I'll give you a second to pause the video and then we'll go over it. Okay, so the answer for 10 is going to be B. The air is going to rise rapidly, forming cumulus, cumulonimbus clouds, and showers. So this kind of ties into the question we just did. If you had unstable air, is your air going to be resisting vertical motion? No, probably not. With unstable air, you're going to be getting a lot of lifting action. And on top of that, you're not going to be forming layered clouds. You're going to be forming more vertically developed clouds. So A is not an answer. We know C is also not an answer because we're not creating steady precipitation with that unstable air. We're going to be getting more drastic weather changes, probably heavy showers, heavy snow. And then D, if we have unstable air, that is most likely not preventing any cloud formation. If anything, it's causing cloud formation. So that leads us to B being the correct answer. I hope that was helpful, and I hope you liked the format of this video. If there are any questions I didn't cover about fronts that you would like me to cover, or any question on meteorology, or any other topic on your written exam, I'll come up with some questions for you and make a video if you just comment down below. Thanks for watching. Subscribe if you can, and like and comment on this video. Share it with maybe another student, and I'll see you guys in the next video.